Hello. This is going to be the documentation of the journey on how these cars, these 24th scale RC cars, are designed and how they work, as well as being documentation of how and why I went through my decisions when making these. Because historically I am very bad at recording my projects, so we'll see if video format makes that any easier on me. But as far as what we're looking at, these are my two, this is my Gen 2 and my Gen 3 24th scale crawlers. They are SCX24 based chassis. They still run worm gear in the axle and the factory SCX24 transmission. Outside of that, they're pretty much custom. Different motors on old versus new, but for different reasons. They are 140 millimeter wheelbase, both of them, and they are both 105 millimeter track width. Trying to keep in that 24 scale for, it would be either the Ultra 4 cars or the trophy trucks. This one, the Gen 2, was meant to look like the Monster Energy Ultra 4. This one I just kind of call the box. No affiliation to any car maker, nothing, so just a simple, easy to print body. Both of these are considered belly draggers, so they sit very low. They're meant to stay like this, hopefully without the use of rubber bands. I'm not really a fan of that solution for keeping the cars low. I'd rather do it over proper spring rates, suspension geometry, things like that, if I can help it. So then the why of building these, I saw what was on the market, the SCX24 chassis. I've seen the aftermarket of what is available for those chassis, and I guess I was not super happy with what my options were. Started with this Gen 2. I did some of the things I wanted to do, and then the Gen 3 is quite a bit more refined than where I started. A lot of these design goals, or I guess the ones I am using, I wanted to lean towards as much 3D printing as possible. Minimize the number of parts you had to purchase pre-made. Makes it a little, well, for me, it makes it much easier to assemble these, to repair them, to maintain them if I can just print the parts that break. Could be an issue that they break, but I'm also fairly rough with these cars, so we'll see after their durability test how they hold up. Next thing I wanted to do was keep them scale looking, or roughly scale looking. I've seen the crazy LCG chassis online where they're just super thin aluminum rails. They have a two-piece rear drive shaft. They do 100% perform better than both of these. I don't contest that at all, but it wasn't really the style or what I was going for. Suspension geometry for me is a big one. Having the proper droop, good damping, good spring rates. I wanted to make sure I could do all of that and incorporate into the car, just to have a really solid baseline. So I was able to do a lot more of that on this one than on the Gen 2, but that was one of them. Dampers. Was not able to do it on the Gen 2, as this thing is just floppy. I was very successfully able to get the dampers to work, or fit, I guess, with the shock oil that works well on them. They don't have too much stiction, and it's been performing very well so far. Second to last design point is going to be minimizing the size of the steering servos, so both of these have very small steering servos. This one's a 4 gram or 4.3 gram servo. This is a 2 gram servo. Talk about how I did that in a little bit, but I see people going to bigger and bigger, the 9 and 12 gram servos, top mount, and that's just a huge mass over the front axle if it's just front wheel steer, and front and the rear if it's both 4-wheel steer. And it just seems a bit much for the weight of these cars. And last thing, as I hope shows through the video, is actually designing the internal layout. This is a little bit more refined, cleaner. This thing is a disaster. Just zip ties and double-sided tape everywhere. It works, but it's difficult to repair, difficult to service, and it's just a mess. So those are kind of the design goals I went into to try to get these where I wanted them. I will start, I guess, with the suspension, as most people tend to see that first, especially with the Gen 2. I'm sure I'm not the only one who's seen this problem, but on these, this is just it's not a factory axle, but it's a stock style axle, just metal, but the screw goes in this way. If I had to get this articulation with a longer shock than these push rods, I run out of travel on the ball end. And I was fighting that with different suspension locations or trying to make little adapters to put the screw from the front, but it was a little too fiddly for what I liked. I ended up using push rod on this car. It achieved a lot of what I wanted, mostly clearing steering out of the way, but this is probably the prime reason why this one is such a mess. Everything is just in the center, and there's just not a lot of room available. On the Gen 3, I updated this. I did away with the complicated push rod. Also has a lot of extra ball joints in here that are tedious to assemble for that system. As you can see, the shocks are not in a traditional location, but they are more inboard, I guess would be the right word for this. They are still mounted to the control arms, but with a 2-to-1 motion ratio. So for roughly every millimeter of travel on the shock, I get 2 millimeters to the wheel. I also have these large cutouts to clear tires. I can go a little bit bigger. These are 55s, and I originally designed them for 60 millimeters, so when the new tires come in, I'll have those on there. But much happier with this. Was able to use the Endura 40 millimeter big bore shocks. These are running 50 weight oil, and at least for this chassis weight right now, it works very well. It's out of the way, nothing protrudes into the center where the electronics tray is, and gave me tons of extra room to kind of manipulate parts and make just wiring easier, and just layout in general much cleaner. Let's see, another one on suspension. Roll axis. A lot of these are, especially the LCG chassis and belly draggers like these, there's not much for spring, and they're always sprung low. And with the crazy setups people have, roll axis is usually affected a lot. So then you'll get cars. These two are not terrible. Get it top down. If your roll axis is too large, as your body rolls, the axle will walk a bit. These aren't terrible. They're not perfect. I've actually seen some of the larger scales crawlers get this right. See a little bit of walk on it. For what I'm building, I was really trying to reduce that to 0. Some people purposely design that into their crawlers, especially for, I would imagine, competition. As they're rolling around rocks, you can actually induce a little bit of rear steer passively when you're driving. But because I wasn't going to go that crazy, and these are really just trail rigs, not so much competition rigs, I really wanted that to be close to 0. And I do think I accomplished that with both of these cars. The steering was the next biggest thing. I already mentioned once that I'm not really a fan of running the giant 12 gram and 9 gram servos up top. So on this one, since I didn't print the axle, I made a vertical mount for this 4.3 gram servo. And I've run this one a lot. I haven't had any issues yet, even with these heavy wheels. With this servo, these are metal geared DS power. They're nothing fancy. I think it's like 0.6 kilogram centimeters. And so far they've worked really well on this. But I was still unhappy with where they're mounted. They get in the way of the upper control arm. Kind of limits what I can do. Still lighter than the large top mount servos. On the Gen 3, let's see how well I can show this. Since I printed the front axle, these are all SLA prints, I was able to fit a 2 gram servo incorporated into the axle housing. I'm missing the steering horn on here, but I have. This is what the housings look like. This one is the 2 gram. Should that servo fail, because it is very small, I have similar mounting for the 4.3 gram. Because I know this servo works, but it was a little bit tighter to fit. So I have 2 options on that. And then in the future, because I do plan on hopefully selling some of these, including the files, this is just your standard top mount. So this will take factory top mounts for the SCX24 chassis, if people wanted to go down that route. But to make this possible, let's see if I can show it on the old car. You can see the kingpin almost a tire width away from the tire. That means that as this tire turns, it's dragging the tire around that pivot point. I think this is why so many people are going with larger and larger steering servos as they get heavier and heavier wheels. These are solid brass, so there's quite a bit of friction, especially when these are warm, hot day outside. So to fix the problem, I needed to reduce the scrub radius. These axles are technically using a plus 8mm axle shaft, but they end up with the same track width. I accomplished that with the wheels, or the hubs, rims, that's what they're called. These are a plus 8 offset. And that allows me to get, it doesn't show too well, but the kingpin angle going and almost intersecting the contact patch of the tire. I think the scrub radius on CAD for this was like 2mm. This significantly reduces the amount of force your steering servo has to put out to overcome as it's turning. I think that's one of the biggest things that allowed me to go with these much smaller servos. I was really happy with how that came out. I don't really have a need to go wider than this, so for now, I think that's where the axles are probably going to stay until someone makes a plus 10 or a plus 12 axle shaft. I don't have the capabilities or the means right now to make my own, especially not 3D printed. Those parts are too small and they will break. The dampers I showed before, they're big when you come to wheel control, as well as the torque twist, but this allowed me to get a nice controlled suspension. I can actually drop this thing, not that they really go fast enough to jump, but still gives very good control over its wheel position. In contrast to this thing, which falls like a rock. Not as important as in the road car, but keeping even and non impulse type loads on the wheels is big for keeping traction. So I was very happy with how this came out. Still get most of the same articulation. Where are we on the design sides? Oh, right. You can also see that this new Generation 3, I've made it much lighter. I minimize parts, I minimize metal parts especially. Old school of thought on this one, to keep the center of gravity low, add more weight towards the bottom. That's where these super heavy wheels, metal links, and it does help, but it also brings the total weight of the vehicle very high. And again, hurts the servo performance and requires a much bigger motor. This guy's running a 2030 censored motor. On the new one, I'm still running a 1525 sensorless. And it's a little shy on power, but being a much smaller motor or lighter car, the smaller motor actually is able to drive it around, get it through parts or obstacles without too much problem. So the train of thought here is, instead of going with a very heavy car, reposition components lower, and then that'll let me reduce the total mass of the vehicle, which for having this much of the car printed helps. The heavy weight of this weighs like 3 or 4 times how much this one weighs, and I have broken parts. Even the brass links, I've bent them, broken rod ends. I've broken these rocker arms a bunch of times. The body, obviously, I've glued this thing back together more than a few times. So I'm hoping that that helps towards this car's durability. And I guess the last point really is the percentage of this car that is 3D printed. So body, obviously, the frame rails are printed, front and rear axle housings are printed, the knuckles are printed. This being the drag link printed, tie rod printed, the motor mounts are printed. So this uses my fixed mesh system. So it'll be motor mount or adapter plate for the transmission. Not the best color for this, but those V notches are for the motor trays. These are the motor trays. I have them from 9-tooth to 18-tooth. So the position of the motor is already set to run. So this is a 10-tooth. And if you put a 10-tooth 0.5 mod gear on here, slide it in that cartridge, you already get the fixed mesh. You don't have to mess with motor position or nothing. I made, you probably can't even see it on this, it's buried, but the old motor mounts were slotted to adjust. And because they were slotted, the head of the bolt didn't have a lot of surface area to clamp. That ended up not really letting me tighten bolts, and they'd come loose, and that got annoying quickly. This specific set's made for mod 0.5 gears, not the factory mod 0.3s, so they seem to be more popular anyways. We have all the control arms are printed, lowers and uppers. I have a couple spare lowers here. They are pop in place ball joints instead of the O-ring style. Not really a fan of those. And the big one for me, might have to zoom in for this, if it lets me. I guess not. But the drive shaft. The steel drive shafts are okay, but I've had issues with the pins flying out of them, even though they're supposed to be press fits. So I ended up designing and printing these drive shaft sets. So I have anywhere from, I think, yoke to yoke of 12 millimeter out to like 140. So I can put together any combination of that. Obviously, I need to durability test these to make sure that they don't fall apart on me. But so far, with the hours I put on them, they look like they're going to last a decent amount of time. And I think that's everything I was thinking about. Obviously, I like the flip-up bodies. Just makes turning them on and taking the batteries out easier. The Gen 2 is probably going to get retired soon just because I do believe the new one's going to be much better, performance-wise. And as this goes on, I have the axles already for sale. Well, not the physical axle, but the CAD files on Cults 3D, as well as that motor set. When I get this chassis done, as in I'm happy with its durability, it will be up on Cults as well. But yeah, that is mostly how I got here. I'm sure I'm forgetting some things, but I'll leave those for next videos. Oh, and next videos will be both of these, hopefully for at least 5 or 6 battery packs of aggressive, not even crawling, but just full throttle running through pretty rocky terrain. If I can find a little nature course or trail around here, park, I'll just drive them for a while, hit as many obstacles as I can. I do want to stress test them and see if there are any weak spots, because I can, at this point, very easily correct them. And yeah, thanks. Stay tuned.